In the last lesson, we looked at individual inequalities, whether they were linear or absolute value. Today, we're going to look at systems of inequalities. So what we're looking for with the solution is the shaded region that satisfies both of the inequalities in the problem. So we'll often describe that as being the overlapping region. So if you look at the first two examples that are kind of given to you ahead of time, you can see the one on the left, there's the blue shaded region coming from below the solid line, and then the red shaded region coming from above the dashed line. So the region that would actually be the solution is this overlapping region in here. So all of the points that are either on the blue line bounding that region or above the red dashed line bounding that region, and all the points in that overlapping region, there are infinitely many points that are part of that solution. When we have parallel lines, there's actually two different things that can happen. One situation is that you can have no solution, like in the example shown here. However, imagine a similar situation. What if we had two parallel lines, and the first problem told us to shade below? If we were asked to shade above the lower line and below the upper line, notice we could have parallel lines and actually have a solution because they would have a shared region in between us. So this is a big difference between a system of two parallel lines and a system of two inequalities containing parallel lines. If you just had lines, you'd have no solution because they never meet. But when you have these shaded regions, you can either have that they don't overlap at all, so there's no solution, like the example that was written on your paper. Or you could have this extra example that I just drew off on the side where you have parallel lines, but they actually do share an overlapping region. And so there is a solution, just like with any other pair of linear inequalities. Let's take a look at a couple of problems that we have to do on our own. So we're going to look at the first one and then at the second one. Having a little trouble getting it to listen to me. I'll pause and reset. All right, let's take a look at the example in the bottom left. First, we have a linear inequality given to us in point-slope form. We can see that it's going to go through the point 1, 1, and that it's going to have a slope of 2. So let's start there, 1, 1, and a slope of up 2 over 1. Drawing all the way across the graph, just like we've been practicing all along. All right, now this is a dashed line because we don't have an or equal to. And we are going to have to shade above. So if I go to do the shading on this, I'm going to shade everything above the line. I'm not going to label yet because if these two lines intersect each other, then I'll be able to use their intersection point as one of my 2 points on this line. So I'm going to hold off on the labeling. All right, the second one is given to us in standard form. So we need to solve for y. So we have 2x minus y is less than 3, and we're going to start by subtracting 2x from both sides. Oops, sorry, I'm having a little trouble with the stylus today. Let's try to make that more clear. So we have negative y is less than negative 2x plus 3. We need to divide both sides by negative 1 to get the negative off the y, and we know from our previous work that that's going to flip the inequality. So we're going to start at a y-intercept of negative 3, and we're going to go up 2 over 1. Notice that's super close to that last line, but it doesn't quite touch that last line that we did. In fact, it's parallel to that line. So this one is also dashed. And this one says to shade above as well. So I'm going to switch colors, and when I shade above, I'm going to be able to see that the part that is the solution is the part that's green, right? Yellow and blue makes green. So the overlapping region is the system, the solution to the system. So notice in this case, the solution is the green. Which actually makes it like that first line I drew is really the only one that even matters for this particular situation. But I do have to come in here and label, so I will label 2 points on each line. Let's take a look at the one involving the absolute value. So we can see that this is going to be an absolute value that opens down because of the negative, with a slope of plus or minus 2 because of the 2 in front of the absolute value. The vertex will be the point 1,5. So I'm going to go to the point 1,5, and I'm going to go down 2 over 1 all the way across the graph. And I'm going to have to make a solid line because of the or equal to. And then I'm going to go down 2 over 1 in the other direction, remembering that my absolute value has to open down. So this side gets the positive slope, and I have a solid line there as well. Although my stylus would really like it to be dashed today. I make sure to put arrows on the ends, and I'm going to hold off on labeling until I see where the other line goes. But I can see that the shading would be above because it says y is greater than. Sorry for the jitteriness in the stylus today. I think it's getting tired of making videos. Now we need to graph that standard form. I've got x minus y is less than 2. So if I subtract x from each side, we have negative y is less than negative x plus 2. And if we divide both sides by negative 1, we see that y is greater than a positive x minus 2. So we're going to go to negative 2 on the y-axis, and we're going to follow a slope of positive 1 all the way across the graph. And of course down in the opposite direction as well. And this one's dashed, which is good because that seems to be what the stylus prefers to write today. So I'm going to label their points of intersection. We've got 1 point at 3, 1. And we've got 1 point at 1, 2, 3, 4. It looks like negative 4. And then that looks like 1, 2, 3, 4, 6. Negative 6. So negative 4, negative 6. So both the points that needed to be labeled on the lines are taken care of, but I need to go back in and label things like the vertex of my absolute value and a couple more points each on the absolute value. And then I need to do the final shading. So this line is supposed to be shaded above because we ended up with a y is greater than. So if I shade above, I can see it's everything above this line except for the part that's sort of inside the triangle of the absolute value. So it's this green shared overlapping region that contains all the solutions to my system.